Welcome to my YouTube channel. So here today we are going to be looking at linear momentum, where we are going to be solving questions that have to do with problems such as inelastic collision. So we are going to look at all these questions and an additional question which I will add at the end. So let's begin. So what is inelastic collision? So inelastic collision is the collision where there is the loss in kinetic energy and also momentum is conserved. Then if we add perfect inelastic collision, that means to say they stick to each other. So this is what we mean. Like for example, if we have this object, we have another object here. Okay, let me make them of similar size. So when these collide, this is what happens. So when this moves like that, then it collides. They form one mass. And this one mass moves together like that. Then, as you can see, at first, if I reverse this, at first it was like that. At first it was like that. So as it is moving, it was moving with its own velocity, this one with its own velocity. But when they merge together, they move with the same velocity. If this doesn't happen, then that's just witchcraft, because how can one move without the other one moving? So they have one common final velocity. So that's very important. So let's now answer questions. Let's begin with this one. So let's say we have this question. We put it here. We have a luxury car with a mass of 1,800. So remember, the formula for momentum is that momentum, symbol P. Momentum is equal to the product of the mass and its velocity, like that. So momentum is conserved. It means to say the momentum that you begin with, the initial momentum, is equal to the summation of the final momentum, like that. So this is, if you haven't watched the introduction, kindly watch that. So the formula for momentum is that, so if you add the momentum of two objects, it should be equal to the momentum of the other objects. If there are two, if there are three, depends. So let's look at this one. A luxury car with a mass of 1,800 stops at a traffic light, is struck from the rear by a compact car of mass 900 kg. The two become entangled as a result of the collision. If the compact car was moving at 20 meters per second before the collision, what is the velocity of the entangled mass after the collision? So there was a car like that. This car is what's the mass? The mass is 1,800 kg, 1,800 kg. Then we have another, so that's the luxury car. It is struck like that. So the two cars form one mass like that. Then they start to move. So as this car is moving, then they start to move like that, as one mass like that. So they want us to now know what velocity were these moving when they were stuck together. So this one, we are going to be saying the summation of momentum, the initial momentum, is equal to the summation of the final momentum. So under this one, we are going to say momentum. We have said that the momentum is equal to the product of mass and velocity. So therefore, we are going to say mass number 1, velocity number 1, plus, so summation is addition, mass number 2, velocity number 2, like that, should be equal to, now remember they are stuck together, it means to say they will form one mass, m1 plus m2. Then we have the final velocity, like that. So our m1 is a luxury car of 1800 stopped at a traffic light, meaning to say it stopped to move. So M1 is 1800 kg times it wasn't moving, so we are going to say 0 meters per second, plus M number 2 is 900 kg, so we are going to say 900 kg times it was moving with a speed of 20 meters per second, so we are going to say 20 meters per second. So this should be equal to, we have the two masses are 1800 kg plus 900 kg, then we have times the final velocity, because they move with one common velocity. So this means this 1800 times 0 is 0 kg meters per second, plus 900 times 20, this gives us 900 times 20 gives us a value of, when we multiply this, we are going to have so 900 times 20, it gives us 18,000, sorry. So 18,000 should be equal to 1800 plus 900. This will give us a value that is equivalent to 2700 kg V final. So we are going to have this plus this, it's just 18,000 kg meters per second should be equal to 2700, just a confirmation, plus 900, 2700 kg V final. We divide by 2700 kg, we divide by 2700 kg. This is going to give us a value. V final will be equal to, so we have 18,000 divided by 2700. This is going to give us a 6.67 meters per second, like that. So this is our speed the two will move with. Let's look at our next question. So this was the additional question I was talking about. Let's move on to our next question. So we have a 70 kg man skating with a speed of 12 meters per second collides with a 50 kg skater at rest, and they cling to each other after the collision. Then we are told finds the kinetic energy lost during the collision. So we are going to say kinetic energy. We know that kinetic energy is equal to half mv squared. So we need to know if we have the initial velocity. So the two, kinetic energy, we have one man is here, another man is there. So this man is moving, this one is stationary, meaning to say this one does not have kinetic energy, but this one has kinetic energy. So we can say kinetic energy initial, we can use KEO to show initial should be equal to half mv squared. So the mass, which man was moving, the 70 kg man skating with this speed, he was moving, then the 50 kg was at rest. So we are just going to consider that and say times 50 kg times what's our velocity. Our velocity is equal to 12 meters. So we are going to say 12 meters per second, then we square it. We are going to have half times 50 is 25 times 12 squared is 144. When we multiply, the kinetic energy initial should be equal to, we are going to say 25 times 144. This is going to be, or the one that was moving was the 70. So we are going to have 35 by 144, which will give us 35 by 144. This is going to give us 5040. So this will be our initial kinetic energy. Then what are we going to have for our final kinetic energy? We need to find that which they at rest, they cling to each other, meaning to say they stick together like that. They stick together as they move. So therefore, we are going to use, so just know if they stick together, they cling together, it means to say they share one common velocity. So knowing that momentum is always conserved, we are going to say momentum is conserved. Therefore, the summation of the initial momentum should be equal to the summation of the final momentum. So using the same approach, we have two men, so we are going to say, let's say the man with mass number 1, velocity number 1, plus mass number 2, velocity number 2, should be equal to, they form one mass, so we are going to say m1 plus m2, then we have the velocity final. So the mass number 1 for the man that was moving, it's 70 kg times the 12 meters per second, plus mass number 2 for the man is 20, the other one was 50 kg times the velocity number 2, which is 0. It was at rest like that. So we are going to have, this should be equal to, mass number 1 is 70 kg plus the mass number 2, which is equal to 50 kg. Then we are going to say times V final like that. So adding those, so 70 by 12 gives us, this gives us a value that is equivalent to, so 70 times 12 gives us 840 kg meters per second, plus 0 won't change anything, plus 0. So we have 70 times plus 50, this will give us 120 kg V final. We divide by 120, we divide by 120 kg, this is going to be V final will be equal to 840 divided by 120. This gives us a value of 7 meters per second like that. So this is our velocity of the two. So we are going to find the kinetic energy final will be equal to half the mass velocity squared. So the velocity is this. Now which mass are you going to use? Remember, these people have more like now begin to move together. So if you can see two people here, then you should come and check you out. So these two people, they stick together like that and begin to move like that. So as a result, they form one mass. So you add this mass, in fact, let me say times the mass, big M. So we are going to have the kinetic energy will be half. The mass of the first man is 70 kg plus the mass of the other man is 50 kg. Then we are going to have times the 7 squared. This gives us half. 70 plus 50 gives us 120 times 7 squared is 49. So our KE should be equal to half times 120 is 60 times 49. So this gives us 60 times 49 will give us a value of 2,940 as our final kinetic energy. So kinetic energy loss, therefore they wanted the kinetic energy loss, so we can say kinetic energy lost should be equal to the initial kinetic energy minus the final kinetic energy. So the initial kinetic energy was equal to, we have 5,040, so we are going to say 5,040 minus the final kinetic energy, which is 2,940 joules. This will give me, if I subtract the two, I'm going to have 2,100 joules. You are going to just put lost, so that this is the kinetic energy lost. like that. So that is how we solve that one. Let's move on to the next question. Let's move to two-dimensional, where we have to isolate the system into x and the y components. So let's begin. An object of mass m1 is equal to 10 kg, traveling at an angle of 60 degrees north of west, having the initial velocity of 20 meters per second, collides with a mass m2 which is 30 kg, traveling at an angle of 20 degrees north of east and the velocity of 35 meters per second. Assume a perfect inelastic collision. Finds the x and y components of m1. So what we are going to do for this question is we are going to come up with a vector. In the actual sense, what is happening is that, for example, if you are looking at 1 coming from 60 degrees north of west means it is moving in this direction. This is where west is. Then the other one, it is moving, let's say for this one, having an initial velocity of 20, collides with the 31 is moving from northeast, meaning to say east is this direction, then they are going to collide at one point. Now this is not how we are going to draw them, but this is the actual meaning. To avoid getting confused, we just draw the vector diagram, the XY plane, in which we are going to now say, if we have our 10 meters traveling at 60 degrees north of west, so north of west is this side, north is up, so we are going to be moving west while moving up like that. So now look, the 60 degrees is north of west. The last thing mentioned is your reference point. So from the west until you meet the line, that's the meaning. So the angle is here, 60 degrees. Then the 20, this other one, the 30 kg one, so this is our m1. The 30 kg one is moving 20 degrees north of east. North of east means it is moving to the east, which is this direction, whilst moving up the north, like that. Then 20 degrees north of east, and the velocity of this. North of east means stand at the east, then start to move where the line is. So this is what we have. So we are going to put our 20 degrees like that. Now the first question says find the x and y components of m1. So m1, for question A, x and y components m1. So we are going to say Vx should be equal to V, the velocity in the x is associated with cos, if you remember your vectors, V cos theta, which will be, V will be, this was moving at the speed of 20 meters per second. So we are going to say 20 meters per second, cos of our theta is equal to, what is the angle? So which one is our m1? M1 was the one that was traveling at the angle of 60 degrees north of west. So you measure the angle from the positive x-axis. So from here, so vectors has come back to here, like that. In fact, vectors are very important. If you're having challenges, you should watch the vector videos. So from here up to here, if this is 60 and this whole angle is 180, so to find just from here up to here, we are going to say, just subtract this. So the angle that is required there, we are going to say this angle will be, let's say we call this angle from here up to here, it is x. We are going to say x plus the 60 degrees. If I add this whole thing plus 60 degrees, it will be equal to 180 degrees. So this means that I'm saying x plus 60 degrees is equal to 180 degrees measured from the positive x-axis. So it will be 180 degrees minus the 60 degrees, which will give me 120 degrees. So this will be my angle measured from the positive x-axis. So this will be the angle that will be used with respect to the positive x-axis. So we are going to say 120 degrees. So if we press everything, we are going to have the value of 20 cosine of 120 degrees. This will be a negative 10 meters per second. So negative in the sense that it's going to the left, which makes sense. Then for the Vy, it will be equal to V sine of theta. The same angle measured from the positive x-axis, which will be 20 sine of 120 degrees. So this will give me 20 sine of 120, 20 sine of 120. This will give me 17.32 meters per second. So we have answered, we have gotten our 4 marks there. Then here, find the direction and the final velocity of the masses. So this one now is quite interesting. For this one, we will need to find the momentum in the x and the momentum in the y, because they were initially moving in different directions. So when they collide, we expect them to even move in another direction. So that's why we have direction and the final velocity of the two masses. So we are going to say, first let us find the momentum, the velocity for M2. So M2 will have Vx should be equal to, V2x should be equal to V2 cos of theta. So this one was moving at a speed of 35 degrees or 35 meters per second. So we are going to say 35 meters per second cos of, what is our theta? So our theta measured from the 20 is here. So measured from the positive x-axis from here until where it is, it's just 20. So we are going to say 20 degrees, which will be 35 cos of 20 will be 32.89 meters per second. So this is our V2x. Let's move it a bit. V2y should be equal to V2 sine of theta. So V2, remember it's 35, sine of the angle is 20 degrees. This gives us 35 sine of 20. This gives us 11.97 meters per second. So this is the V2 y like that. Then after that, we are going to isolate the momentum and find the momentum in the x and the momentum in the y. So remember, it's moving both in the x and the y, so we have to isolate the momentum. So we are going to say momentum in the x. So remember, we are going to say M1 V1 plus M2 V2. Now I'm not putting x because the title, it's important. If you just put momentum in the x, it means you're dealing with the momentum in the x. So these, when they collide, remember they are perfectly inelastic, meaning to say they stick to each other. So we are going to say should be equal to M1 plus our M2. Then we are going to have V final like that. So we have our M1, which is equal to, M1 is 10, M2 is, where's M2? M2 is 30. So we are going to M1, we are going to say this will be our 10 kg times our M1, our V1, velocity number 1, which was for M1. We found it, the velocity in the x to be negative 10 meters per second. So we are going to have negative 10 meters per second. Then we have plus our M2 is equal to 30 kg. Then we have our velocity number 2, which is we are dealing with the x for M2. So the velocity in the x for M2, we have found it to be 32.89. So we are going to say 32.89 should be equal to the summation of the masses. Let me reduce this a bit. So the summation of the masses, so we have 10 kg plus the 30 kg times velocity final. So this velocity is in the x direction. So 10 times negative 10 will be negative 100 kg meters per second. 30 times 32.89, this is going to give us a value of our 986.7. So this kg meters per second. So this should be equal to 10 plus 30 will be 40 kg times our V final x. We divide the 40 kg. We divide by the 40 kg. This gives us, when we subtract, let us first subtract 100 minus negative 100 plus 886. It will be positive 886.7 kg meters per second over 40 kg should be equal to VFX. So our velocity in the x, we are going to have 22.1675 meters per second. So that is the velocity in the x. Then from there, we are going to go to our momentum, because momentum is both in the x and the y. Momentum in the y. This momentum in the y will be equal to, same approach, M1 V1 plus M2 V2 should be equal to, they form one mass, V final in the y. So that's the V final in the y. So what is our M1? Our M1 is equal to 10 kg times, let me just put the brackets. What is our speed in the speed of the mass number 1 in the y? It is 17.32. So we are going to say 17.32 plus our mass number 2, which is our 30 kg, times our velocity number 2 in the y direction. So just be careful. So y direction, velocity number 2 in the y, so V2y. Label your work clearly. So we have 11.97 like that. Then this we are going to have should be equal to, mass number 1 is 10 plus 30 kg times the VF in the y direction. So we are going to have 173.2 plus our 30 times 11.97. This is going to give us 359.1 should be equal to 10 plus 30 will be 40 kg times VFY. So when we add our 173.2, this is going to give us 532.3 over our 40 kg meters per second should be equal to Vf in the y direction. So when we divide our 40, we are going to get 13.3075 should be equal to Vfy. So when you find the velocity in the x and the velocity in the y, it is giving us this. Therefore, to find the magnitude, so as long as you want the magnitude, it is the Pythagoras theorem. So you are going to say we want the velocity. First, let's look at what we have been told. The direction and the final velocity. Like that. So what are we going to have? So for the velocities, the velocity in the x squared plus the velocity in the y squared. So this is, we use the Pythagoras theorem for anything to find the magnitude. So we are going to have the square root of our Vx. Vx is equal to 22.1675 squared plus, so this was the velocity in the x, the velocity in the y, which is equal to 13.3075. This will be the magnitude should be equal to, so we square this. When we add these, we are going to have 22.1675 squared plus 13.3075 squared. This is going to give us 668.79. When we find the square root of this, we are going to have the magnitude of the velocity. You can use this, which is always positive. If you are looking at the magnitude, it will be 25.86 meters per second, like that. So that's how you find the magnitude. Then to find the direction, never forgetting vectors, your tan of theta should be equal to opposite over adjacent. So the tan of, to find the direction is the angle, so theta should be equal to tan inverse, when this goes this side, tan inverse of opposite over adjacent. So our theta should be equal to tan inverse, not just tan inverse of our opposite. Opposite is our opposite, which is in this case, for this one, we are going to use our opposite is the y component, so Vy over the Vx. So remember, Vy is 13 point, don't interchange them, 13.3075 divided by, you put them in brackets, divided by our Vy, our Vx, which was found to be 22.1675. Like that. So our theta should be equal to, if you press everything, tan inverse of, open brackets, 13.3075 divided by 22.1675, we are going to get 30.98 degrees, like that. So we have not this one, but the one for the ego now. We have a 1 kg falcon is traveling at 25 meters per second at a downward angle of 35 degrees as shown in the figure below. It catches a 0.5 kg pigeon from behind in mid-air. What is their combined velocity after impact if the pigeon initially the pigeon's initial velocity was 7 meters per second directed horizontally. So the pigeon is moving like that, then the falcon is at an angle. So the pigeon's velocity is purely in the x direction. So therefore, what are we going to do? So let's first resolve the falcon's velocity into x and y components. What are we going to have? Let's move these a bit. Copy this. So the first thing is find the falcon's velocity. So let's resolve. So its initial velocity is for, let's say I call it v1. So its v1x is equal to v cos of theta. So the aim is that when it catches this, it starts to go up. So we are going to consider downwards to be negative. So therefore, we are going to have our v1x, then it is moving, as it is moving this side, we are going to consider it to be positive x. So v1x is equal to, what is the velocity at which it is moving? It's moving at 25 meters per second. So we are going to say 25 meters per second cos of the angle, which is the 35 degrees. So we are going to have, when we press our 25 cos of 35, this is going to give us a value of 20.48 meters per second. Let's move this a bit to this side. Then when we get this other one, our v1 y for the falcon will be equal to v cos of theta. So taking downwards to be positive or negative, we are going to say negative, its velocity is 25. Then we are going to say, so the y is associated with sine. So we are going to say sine of our theta is equal to 35 degrees. So it will be negative. So 25 sine of 35. 25 sine of 35. It will be equal to a negative 14.34 meters per second as it is going down like that. So this is v1 y like that. Considering that we have found those, so our aim is for us to find the velocity after impact if the pigeon's initial velocity was 7 meters per second directed horizontally. So we need to find, let's just name also. So this is for the falcon initial velocity for the falcon, initial velocity for the falcon, then the initial velocity for the pigeon, remember the pigeon is moving purely in the x-axis. Therefore, it means to say for the pigeon, v1x is equal to, we are going to have, it is moving just in the x, so all its speed is in the x. So we are going to say it is 7 meters per second. So we are going to say this is the 7 meters per second in the x. In the y, it is equal to 0 meters per second because it was just moving in a straight line in the x-axis. So its y is equal to 0. Then after we do that, we are going to do the same thing we did for the previous question by saying momentum in the x, momentum in the x. So the momentum in the x is equal to, we are going to have same thing. So the summation of initial momentum is equal to the summation of the final momentum, which will be equal to, we are going to say m1 velocity 1 plus m2 velocity 2 should be equal to when it holds the bird, they form one mass. Therefore, we are going to say it is not letting go, so it is 1 mass. So mass 1 times mass 2 times the final velocity in the x-axis. So this is going to be our m1, which is the falcon, is 1 kg times our, let's move this, times our speed for velocity number 1 of the falcon. If you recall, we found the x for the one in the x is 20.48. So we are going to say 20.48 like that meters per second, plus our mass number 2, which is equivalent to 0.5 for the pigeon, times, it is purely in the x-axis, so we are going to say times 7 meters per second should be equal to, so we add now the mass of the falcon plus the mass of the pigeon times the v final in the x-axis. So 1 times this, it will be 20.48 kg meters per second plus 0.5 times 7 will give us 3.5 kg meters per second, which should be equal to 1 plus 0.5, it will be 1.5 kg v final in the x. So when we add our 20.48 plus our 3.5, this is going to give us a value of 23.98, should be equal to 1.5 VFX. So we divide by 1.5, we divide by 1.5. So our V velocity in the X will be equal to 15.99 meters per second. So that is our velocity in the X. Then find the momentum in the X, or in the Y, sorry. This one should be equal to the same thing, m1 v1 plus m2 v2 should be equal to m1 plus m2 times the velocity in the Y, like that. So just by doing this, by putting, don't forget the title, momentum in the Y. So our momentum for the falcon, it's 1 times 1 kg times the velocity in the Y for the falcon was found to be this one, a negative 14.34 meters per second, plus the mass number 2 of the pigeon is 0.5 times our velocity in the Y direction. The pigeon was moving purely in the x-axis, therefore its velocity in the x is 0 meters per second, should be equal to our mass number 1 is 1 kg plus our 0.5 kg, like that, then times our VF in the Y direction. So this will be our 1 times negative 14, it will be negative 14.34 kg meters per second, plus 0.5 times 0 is 0, which won't change anything, so it's okay if we omit it, should be equal to 1 plus 1.5 is 1.5, or 1 plus 0.5 is 1.5 kg VF in the Y. So when we divide our 1.5 kg over 1.5 kg, we are going to get 14.34 divided by 1.5. We are going to have our negative 9.56, which shall be equal to the velocity in the Y. Therefore, to find the magnitude of the velocity, so the magnitude, you are going to put this should be equal to the square root of the square of the velocity in the X plus the square of the velocity in the Y, which will be equal to the velocity in the X is equal to 15.99. So we are going to put 15.99 squared plus negative 9.56 squared, which will be, if you add this, so we have 15.99 plus, you put that number in brackets, negative 9.56 squared, it is going to give us 107. Sorry, let me press correctly. 15.99 squared plus our negative 9.56, don't forget to put it in brackets, squared. That will give us the square root of 347.07, like that. So the square root of this value will give us positive 18.63 meters per second. So this is our magnitude of the velocity. So to find the direction, we are going to say direction should be equal to the tan of theta should be equal to opposite over adjacent. So the tan of our theta should be equal to, in this case, the opposite is always the velocity in the y over the velocity in the x, never forgetting your vector knowledge. So we are going to take the tan this side. We are going to have theta should be equal to tan inverse of our vy over our vx, which will be the tan inverse of our vy, which is, if you recall, our vy, the value we found for vy was negative 9.56. So we are going to say negative 9.56 over the vx is having a value of, vx was found to be 15.99. So we have 15.99 like that. So our theta should be equal to, so our tan inverse of this value, tan inverse of our 9.56 divided by 15.99 will give us a value of 30.87 degrees. So it's negative 30.87 degrees. Now let's look at something. So already our angle is such that we have, if we draw the x or y plane, remember x is positive 15.99, let's just say 16. Then our y is a negative, it was going down, it was a negative 9.56. So we have something like this. So the angle, this angle is always made between the x-axis and that line. So this angle is here, which is our 30.87 degrees, like that. So this is the angle. So you can say that this is the angle is that theta is equal to 30.87 below the positive x-axis. If you want, you can measure it from here, moving to here, measuring it from the positive x-axis. It will be the 30.87 plus the unknown angle, which is the whole thing, should be equal to 360 degrees. So we are going to have our x is equal to 360 degrees minus 30.87 degrees. This is going to give us, if we subtract our 360, we are going to have 329.13 degrees from the positive, not from, measured, very important, measured from positive x-axis. So measured from the positive x-axis, it is this angle. Or you can just leave it like this, below 30.87, below the positive x-axis. Let's solve our last question. So this is our last question. We have a car of mass 800 kg traveling due north collides with a truck of mass 2000 kg traveling due east. Then we are told after the investigation by the traffic officer, it was determined that the truck was traveling at 36 kilometers per hour before the collision. After the collision, the car and the truck stick together and move in the direction 53 degrees north of east, neglecting friction. Determine their common speed after the impact. So they have told us that it was determined that the truck was traveling at 36 kilometers per hour before the collision. Now the truck, we are told here that a truck of mass 200 is traveling due east. So this truck, we are told where it was traveling. So we have, if we draw our XY plane like this, we are going to have something like the truck is moving due east. So this is east, this is west, this is north, this is south. Then we are told that after the collision, so let's look at the car. The car was traveling, the car of mass 800 kg traveling due north, collide. So this one was traveling due north like that. So this one, they collided and they began to move in the direction 53 degrees north of east. So north of east means go to the east while going up. So it will be like this. Now north of east means begin from your east until you meet the line. So the angle must be here 53 degrees like that. So if this is the case, we have been told that this truck was moving at a speed of 36 kilometers per hour like that. This one we are not told. So therefore, in order to find the common speed, at least we have the velocity in the x. So that is what we are going to use, the momentum in the x. So we are going to say momentum in the x. So momentum in the x will be equal to the same thing. So these stick together to form one mass like that. So we are going to say M1 V1 initial. In fact, it's already known. So the summation of the initial momentum should be equal to the summation of the final momentum. So we have, let's call the one going up, which is the car. The car was moving up to be M1. So we are going to say M1 V1 plus M2 V2. So this title, very important, should be equal to, they collided and they formed one mass. So it's M1 plus M2 times the VF of X like that. So we are going to have our mass number one, which is M1. Let's call M1 to be the car. So M1, let's just include it. M1 should be equal to 800 kg. M2 should be equal to 2000 kg. So we are going to have 800 kg like that. Before that, let's convert the speed. So the speed of the truck was 36 kilometers per hour. So converting this, we are going to have 36 using the chain link conversion over 1 hour. We are going to put our hour, since it's up here, we want to convert to meters per second. So our hour is up here, so it has to go up. So we have 1 hour. In 1 hour, there's exactly 3,600 seconds. Then we have times. So this hour and this hour have gone. Then the kilometer, since the kilometer is up here, it will be taken down here. In 1 kilometer, there is exactly 1,000 meters. So that this and this cancels. So we are going to have 36 by 1,000, it's 36,000 over our 3,600 seconds when you multiply. So we are going to have 36,000 divided by, so dividing this we are going to have 10 meters per second. So that is the speed of the track. So M2 is the track. That's the one they have given us. So the track was traveling 36 and the track was moving in the east. Now let's replace. So we have 10 meters per second. For the car, do we know the x? The car was moving purely in the y direction, meaning to say its x speed is 0 initially. So we are going to have M1 is 800 kg times the speed is 0 meters per second. That is in the x direction. Remember, this is momentum in the x. Then we have plus our M2 is 2000 kg times it is moving 10 meters per second. So reducing this, we are going to have this should be equal to our M1 plus M2, which will be 800. I'll put the kg outside, plus 2000 kg. Let's just reduce this a bit so that we have velocity final in the x direction. So this is 0. 800 times 0 is 0 plus 2000 times 10. This gives us 20,000 kg meters per second should be equal to 800 plus 2000. This gives us 2800 kg velocity in the x. When we add that, we are going to have 20,000 kg meters per second should be equal to 2800 kg velocity in the x. We divide 2800 kg. So the velocity in the x should be equal to, we have 20,000 divided by 2800. We are going to have 7.143 meters per second. So this is the velocity in the x. Now when they are asking about their common speed after the impact, they are talking about the actual speed. So this is now where you are going to say, we know that velocity in the x is given as the actual velocity times the cos of theta. Now the only reason why, let's compare it with the Falcon. This one, let's say when you find the velocity in the x for the Falcon, for this one, let's say you find the velocity in the x, you cannot from here say velocity in the x is equal to v cos of theta. It is okay, but you don't know the angle at which the Falcon began to move with after it caught it. But here we are provided that it after impact they moved with the cos of 53. So if you know the angle already, it means to say you can be able to find the resultant speed just by using one resultant velocity in either the x or the y. So we are going to say Vx, we know that Vx is this, so we are going to say 7.143 should be equal to our velocity, we don't know, times the cos of the angle is 53 degrees. That is the angle it began to move with after impact. So we divide by the cos of 53 degrees over the cos of 53 degrees. So our V should be equal to, we divide this by the cos of 53. This gives us a value that is equivalent to 11.87 meters per second, like that. So this is the speed that was required. Last but not the least, we are looking at the velocity the car before the collision. Now this one, the car was moving purely in the y-axis, so we are going to use the y. So we are going to say momentum in the y. Momentum in the y will be equal to, we have same approach, m1 v1 initial plus m2 v2 initial should be equal to, we are going to have m1 plus m2 times the velocity in the y, like that. So what we are going to have is our m1, which is the car, is 800 kg times the velocity of the car, that is the initial, we don't know. So we are going to say plus the mass of the truck is 2000 kg. Then one thing that we don't know is, we know to say it's 0 meters per second. This truck was moving purely in the x-axis only, so meaning to say its y is 0. So the initial is 0 for that one. So we are going to have 0 should be equal to, let's reduce this, so this is going to give us m1 800 kg plus 2000, then we put the kg, then we have our vf, due to space I'll put it. So we are going to have 800 times v1, it will be 800 v1 initial plus the 0, 2000 times 0 is 0, so we leave it like that. So this should be equal to 800 times 2000, it will be 2800 kg v final y, like that. So we divide this value, let's just forget about, okay, not there. Now we can put what is our vfy. We know that vfy is equal to v sine of theta. So we can be able to put, so we have 800 v1 initial should be equal to, this one wasn't at an angle, so 2800 times, where there is vfy, we are going to say v sine of theta. Now we know the angle, we know the velocity because we have found it. So we are going to have 800 v1 initial should be equal to 2800 times our velocity. This velocity is equal to, we found it to be 11.87 meters per second times the sine of the angle 53 degrees, like that. We divide to make v1 the subject of the formula. We divide 800, we are going to have v1 initial should be equal to, so we multiply what is on top, 11.87 times 2800, then we multiply times the sine of 53. This is going to give us 26,540.89643 over 800. So our v1 initial will be equal to, when we divide our 800, so this tells us that the initial speed in the x direction is found to be 33.2 meters per second. So this is how we find that. So that is how we find that. So that means to say the velocity of the car should be equal to 33.2 meters per second. So this is how we find that. So otherwise, that's that for collision under inelastic momentum. So thank you very much for watching. Hope you would like, subscribe, and be able to not miss out anything. See you in the next tutorial.